Now that we have become friends with correlations on the one hand and regression coefficients on the other hand, I should stress one last time that they really describe two aspects of the relationship between two variables. There is the story of strength. You can ask, how well do my points in the graph, how well do my individual participants follow the line? So if you come out of the calculation with a correlation of 1, if it turns out that you have a perfect correlation, then I suppose that your scatter plot has to look like this, right? The thing is, sure, the correlation coefficient guarantees that there is a positive trend, a perfect positive trend in this particular scenario, but that trend could also look like this. So you should make sure that the appearance of the regression, the appearance of the trend is it's not expressed by the correlation as such. The correlation only expresses whether the trend is positive or negative and how strong that is. But maybe the number of drinks, for example, increases much faster with every additional appetizer. Similarly, you can say, well, I want to describe how the regression line actually runs. So let's calculate those regression coefficients. And I have, at some point, these regression coefficients, an intercept of 9.123. I'm just giving you an abstract example here, right? And then we have a slope of 0.097x. That must mean that my scatter plot looks like this. Well, I suppose it could also look like this. So that's the point. The regression coefficients do not express how closely the points follow the trend. You need the correlation coefficient for that. So it's really two different kinds of statistics to describe a different aspect of the association, and you really need both the regression equation and the correlation coefficient to get a complete picture. They don't tell the whole story on their own.